Hello and welcome. My name is Tony Kingham and I'm talking to our old friend John Howell about vehicle screening with X-ray technology. Welcome, John.
Thank you for inviting me, Tony.
Pleasure. Okay, John is the IED EOD security specialist for UK company 3DX-Ray. John, can you tell me a little bit about your background in EOD?
Yes, Tony. I started in EOD in the United States Marine Corps in 1987, and I was in the Marines in the explosive ordnance disposal field for 12 years. When I got out of the Marine Corps, I went to work for the U.S. Department of State with their Diplomatic Security Service, with their explosive detection program, and also their explosive countermeasure unit. And my job was counter IED training overseas at all our embassies and consulates throughout the world. So I've been literally everywhere. I did that job for over 8 years, and after that, I went into work for the United States Marshal Service. And the U.S. Marshal Service here in the U.S. runs all of the judicial security, so every federal courthouse in the United States is their responsibility. So I did all their counter IED training for their special agents and also their court security officers for the entire country of the United States. I also went back into the military when the Gulf War kicked back off again, and was in the U.S. Army National Guard with an explosive ordnance disposal unit out of West Virginia. And after that, my wife retired from the Marshals, and I went into the private sector, and I started working with a couple different companies. I started off with one company called DSA Detection, and we did a lot of counter IED training there and developed a lot of counter IED training products. And the focus has always been X-ray, especially with me. And then right now I'm working, as you know, with 3DX-Ray, and we also have our own company here in the United States called SVS Countermeasures Training. And again, the focus is counter IED X-ray training for bomb techs and also checkpoint security mail screeners.
Okay, so a very broad and deep experience. Okay, I'm going to jump in with our first question. What types of X-ray technology are currently being used to screen a potential vehicle threat?
Throughout the world, there's a couple different technologies that are going to be used. So if you're looking at non-bomb technician type technology, a lot of systems will be a very large, high KV, it's in the MV ranges that screen the entire vehicle. These are used mainly at cargo inspection points or very high threat areas. These systems do the entire vehicle, and they're very expensive and they're very large. From the bomb tech side, there's never really been a dedicated product that's been for screening of vehicles. So they've had to use their portable X-ray technology to try to X-ray vehicles. And what we have out there today has pretty much been sort of an ad hoc type configuration of systems, which has mainly been focused with the computed radiography portable X-ray technology.
Okay, thanks for that. So why screen with X-ray instead of just hitting it with a boot banger or something similar? I'll let you explain what a boot banger is.
So a boot is the English term, proper English term for the trunk of a car. So the bonnet is actually the hood. So it's the boot and the bonnet. So the system was to develop the boot banger, which is basically a water charge using sheet explosives that's put underneath the trunk or the boot of the car, and is used to knock everything out of the trunk and disrupt it. It's a water disruption charge. So that's where the name boot banger comes from. Over in places like Iraq and Afghanistan, when we were dealing with V-beds over there, that was the standard tool for dealing with any type of suspect or suspicious vehicle. We would hit it with a tool like that. When you start getting stateside into like domestic areas where there's a lot of civilian population, it really depends on what part of the world that you're going to be in and what type of threat they've been dealing with historically. So like with the UK, they're more prone just to blow things up, where here in the United States or other parts of the world, there's a lot more things they have to go through before they can get to that point. So the X-ray has become a tool for a lot of bomb technicians who just cannot blow something up. They need that tool to investigate the vehicle to see if they can, potentially see something inside of the trunk or in other areas of the car to verify there is a threat before they can actually use something like a boot banger. Now, if you sit down with a bunch of bomb techs and talk about this, you'll get some pretty good arguments. But it gets political just depending on where you're at in the world. And that's kind of why the X-ray system, the portable X-ray system, is being utilized today by bomb technicians to investigate vehicles for a potential threat.
Okay, thank you. So how effective are the current X-ray screening technologies at clearing a vehicle?
They're not very effective, to be perfectly honest with you. I've used all of them. I've used all the different CR systems that are currently being used to screen vehicles. And what they use is a CR system, or computed radiography, is a phosphorus plate that they shoot an X-ray at, and then they have to take the plate back to a scanner, and then the scanner will download the image that they can look at. So the first problem with these systems is the fact that the bomb tech is spending a lot of time downrange on that vehicle. So he has to go down and deploy that X-ray system with the CR plate. Then he has to take the X-ray, then he has to go back downrange again, and we call this time on target. And with these systems, it's an extensive amount of time on target for the bomb technicians. The other problem is they don't make, when you're screening a vehicle, it's a large item. So when you're trying to use the standard size plate, which is typically 35 by 43 centimeters or 14 by 17 inches, that's not a lot of imaging area to try to see what's going on inside of a trunk. So what they'll do is they'll do what we call mosaics with these CR systems. They'll get 4 to 6 of these panels together, and they have a way of putting them all together in one, and it's like a blanket that they'll lay next to the vehicle, and then they'll attempt to shoot a much larger image. The problem with that is it just basically gets into X-ray physics a lot, that when you start getting a larger surface area that you need to illuminate with an X-ray, you have to back up your X-ray generator so the cone gets complete coverage. And anytime you start backing that X-ray generator up, you start losing capability. So when you start looking at things like cars, trucks, or large vehicles, that distance can be pretty far. And it almost just basically nullifies your ability to really penetrate anything. And then when you start looking at cars, there's a lot of very dense materials that you're potentially going to be dealing with. So it just becomes mathematically, from a physics side, a not very effective tool. So some of the things, the articles I've done is I've shown the images with these systems trying to shoot through the trunk of a car from a side-to-side shot. And you get these large black areas that, you know, when they get that, the bomb techs will go back to their system and say, well, I'll just shoot another 99 pulses. And they keep shooting 99 pulses again and again, hoping thgoing to penetrate that area to see what's inside there. And my experience is once you shoot 99 pulses and you shoot 99 more, you're done. You're not going to penetrate from that point on. So it's an okay tool. It does provide some capability as long as there's not a lot of dense material in the way. But as far as time on target and really being effective, it's not a great tool that they're using currently with the CR systems.
Okay, you mentioned side-to-side scanning. Why is this technique historically been used mainly?
I've actually tried to research this to figure out if there is a physics behind trying to do that, and there's not. And what I've come up with is basically the technology we had available as far as positioning it. That was the most effective way to do it. I mean, basically, it was the only way to do it. So if you start looking at the generators that are commonly used with the CR systems, it's going to be your golden X-ray pulse generators. And the only repositioning method you have with those is typically a tripod. So the tripod, and the way people think is they'll start on one side of the car, the side to side, and shoot from one side to the other. Why nobody kind of looked at shooting from top down, I honestly don't know. But when you compare the two, and that's why we're talking, there's a huge difference in the image quality and the overall physics behind getting a good X-ray between a side-to-side shot and a top-down shot.
Okay, so how does the 3DX-Ray LS1 system make the process more effective?
Well, the first thing is the size of the panel. So the LS1 system uses a technology that we call line scan. So line scan is a lot different than the amorphous silica technology that's out there today. As far as how it reads X-ray, it's exactly the same. They have the same scintillators and photodiodes and detector arrays. It's just the line scan system is only a strip of these detectors that travels from one end of the detector panel to the other. With an ASI panel, it's a whole entire bed of these that's in a glass substrate or amorphous silicon, and they're very fragile. And you can't make those very large. So when you look at the DR digital radiography technology, that's the size was just never there. The biggest they make these is around 17 by 17, or the 35 by 43. They're just not big enough to do a car, and that's why people were using the CR systems. And the next problem is with that small panel, it's very costly, it's very fragile, and it's not large enough to really do a vehicle. So with the 3D X-ray system, because it's line scan, we can make our panels very large and at much less cost. So it's a much more intuitive, and it's been engineered basically for the counter IED mission, where the ASI panels or amorphous silicon panels, even the CR panels they're using, were originally designed and sized, and that's what's important. They were sized to X-ray a person. They were never sized to X-ray a vehicle. So when you have an LS1 panel, you're looking at well over double the size from an LS1 panel in comparison to your standard 14 by 17, which gives you a much larger surface area in that initial scan, where with the current technology, the CR, the DR, it's not going to be as effective. The other thing is that I'm not having to back my generator up so far away for these large mosaics that they use with the CR system. So once you start going 4 to 6 panels, the 35 by 43s, in my experience, you're just completely wasting your time unless there's no dense material between you and the generator and the X-ray panels. But when you start hitting dense material, those systems just, they won't penetrate. So with our system, that's the one aspect, is we have a much larger panel than anybody else on the market. And the other thing is the iGen. The iGen generator has a stand that comes with it that lets you shoot from any angle, almost 360 degrees. And it has large rubber feet on the bottom of it that allows you to position it on the top of the vehicle. You can even put it at hard angles like this and aim it straight down, and it won't move. So it's the perfect tool for doing a top-down attack on a vehicle. So the first thing I did is when I saw this capability, I tested it and I compared it to the current CR systems, shooting side to side and then shooting from top down. And the difference was just staggering. I mean, absolutely staggering on the amount of imaging and what you were able to see versus a side to side shot.
Okay, well, you've answered some of my questions, but what is it that makes a top-down attack more effective than side to side?
There's a lot of physics that you're going to be talking about as far as why this is better. The first one's going to be the distance. So anytime you can shorten the distance between your X-ray generator and your actual detector, whether it's a CR or digital radiography, you're going to get much better response with those accelerators and photodiodes, because you're getting more energy on the target, and that just makes a huge difference across a lot of spectrums. Your image resolution, your penetration is going to improve greatly, which is key. You want a lot of good penetration, especially with doing a vehicle. And that's the biggest thing, is that distance. The other thing is the angle. So when you're going to X-ray something, and I teach guys cabinet X-ray interpretation, and I also teach bomb techs. But if I take a box or a suitcase, we'll use a suitcase as a perfect example, and I place it on an X-ray belt, that generator shoots from the bottom up. So if I were to stand that bag up on its end, that would be a ridiculous, unintelligent angle to try to shoot that at. So they've literally engineered those cabinet X-ray systems to have that bag laying down where the shortest distance is what they're trying to penetrate through. And then everything's going to be laid out at an angle that makes it much easier to do X-ray interpretation. So think about the trunk or the boot of your car. I'm going to take items and lay them down inside the back of that car from either this direction or this direction. And there's this flat surface there that they can lay on. And then below that, you'll have where the spare tire and things like that are, and you can have things laying down inside there. If you're shooting from this angle, and I'm trying to see all these things lined up like this, you're not going to be able to do X-ray interpretation of those items. You're not going to be able to look at them in an X-ray image and go, oh, that's a car jack, that's a road flare. You can't make that determination from that angle. So that is another massive reason why the side-to-side shot is not good, especially on the trunk. Now, if I were to shoot it from this direction, all those items that are lined out show up perfectly, and I can see their shape and I can make an identification as to what it is, whether it's not a threat or whether it is a threat. The other aspect of that is if you're shooting side to side on, let's say, the doors, and you think there might be something hitting in the door panels, like drugs, or it can even be an explosive device. That door and this door, when you shoot from this angle all the way to this angle, are now combined in your X-ray image, okay? Because it all overlaps. So that's another example of why it's just a very poor way to try to figure out which door I might have something in by shooting through both doors simultaneous. You got the distance problem, and you also got all this other stuff overlapping. Another example is, let's say something's inside the glove box of a car, which is typically over the window. If I'm going to try to shoot side to side of that, you're getting everything. You're getting the dashboard, you're getting the AC system, you're getting the radio, you're getting the steering wheel, you're getting everything. And you're never going to be able to do X-ray interpretation or image interpretation of that. Now, if I shoot from down through that window, through the glove box to the bottom of the car where I have my panel sitting, you can see perfectly what's inside that glove box. So just from those items, the angle being the most important, and then the distance, the top-down method blows away shooting an X-ray on a car from side to side.
Is more KV the fix?
A lot of people think it is, and it's actually not. And I'll explain to you why. So most portable X-ray generators that are being used by bomb techs are going to be the pulse systems, which are the XR200 or the XR150, and both of these operate at about 150 kV. So when you're trying to shoot through a car, which the typical thickness of the metal is going to be about 3/4 of a millimeter. That's very thin. But when you start trying to shoot with 150 kV from one side of the vehicle to the other, the distance, the size of the panels you're trying to illuminate, and then all that metal, you know, in the door frame and the trunk, all this stuff is going to start overlapping, because you're going to get more overlap from the construction of a vehicle from a side-to-side shot than you will from top down. So a lot of people think the underneath of the car is very thick. It's not. These things are all unibody construction, and you're still looking at that about 3/4 of a millimeter thick metal. It might be overlapped in some places, which is, 1.5 millimeter. But when you have 5 or 6 of those from a side-to-side shot, you drastically increase the amount of metal you're trying to punch through. So it's not a KV issue. It's what's in the way that I'm trying to shoot through, and what's the more effective way of doing it.
Okay, that's very clear. One final question. What sort of operational scenarios can you see the top-down system being used?
From a bomb technician perspective, if you're having to screen vehicles for a potential threat, it's the better way to do it. You're going to be able to clear the vehicle faster, because you're going to be able to get a much more clear, concise picture that does and penetrate a much better. So in one shot, you're going to be able to go, okay, I have something here or I don't. I train bomb techs on X-ray interpretation. So I'll give you an example. I was training a US Air Force bomb team, and I let them set up and run the scenario the way they would. And we had the device in the trunk. And it took probably an hour, okay, just to get everything set up and shooting multiple X-rays. And they still could never see the device. So then we switched over and did a top-down shot, and immediately in the first shot, they were plain as day able to see the IED. So that's just an example of why it's just so much more effective for vehicles. And the other side of the coin is you can use this systems for customs and border protection. So if they're just setting up remote checkpoints looking for drugs or paraphernalia or contraband, this system is perfect for that. And it allows you to shoot at multiple angles, gives you a large LS1 panel target to shoot and get a perfect image. So it's just a much better system for customs, for IED work. You can even use it for surveillance work, looking for bugs inside walls and things of that nature. So all around, to me, using the constant potential generator, the large size panels with the line scan technology is the future of portable X-ray technology for bomb technicians and security personnel.
Okay, what about that's VIP protection, critical infrastructure, major events? Is there a role for these systems and this technique in those areas?
Yeah, there is. So again, because of the size of the panel, you're able to take larger scans. And if, let's say, you're doing VIP protection and you're searching a room for potential threats or surveillance devices, that larger panel is going to allow you to clear that room much faster. And the other nice thing about the line scan technology using a constant potential generator versus a pulse generator is that you're able to do what we call accurate materials discrimination imaging. Now, the bomb tech community is not very familiar with materials discrimination imaging, but that has been the standard in the cabinet industry world for years. Everything they do in imaging is called materials discrimination. With a line scan system and a constant potential generator, if I'm searching a wall, you're able to get that materials discrimination imaging and be able to see much better and get way more information. And this materials discrimination is again, it's the standard in the cabinet X-ray world because they compared grayscale imaging versus materials discrimination imaging and did study after study on this and found it is absolutely way more effective. So with the line scan system, there's just so many advantages based on the technology and how it's engineered over what that's been historically the type of technology bomb techs have been using and other security personnel for portable X-ray systems.
Okay, John, that has been incredibly interesting and useful. Can you tell me where people can find information about the 3DX-Ray system?
They can just go to our website. Our website has all the information on there. It's 3DXray.com. Just go there. There's a contact us form on there, a lot of different pages about the different products and different areas we work in. We also provide training, advanced training for not only cabinet X-ray personnel, but also portable X-ray system training. And everything's on the website. If they want to get a hold of me, that's the best way to get a hold of me from there. And we've got people that operate all over the world. Our systems are used worldwide. In fact, we have just deployed a system in Canada with the Royal Canadian Mounted Police, and we're getting ready to deploy one with the Boston and Cambridge bomb squads here in the United States.
Fantastic. Okay, John, it was great to talk to you again. Very illuminating. Thank you for your time, and goodbye.
Thank you.